Hi everyone. In this lesson we're going to consider vector addition where our vectors are in Cartesian or rectangular coordinates. So I have two vectors A and B. A is the vector 4, 1. We can see A over here on the grid. So 4, 1, 4 steps along the x-axis and 1 step parallel to the y-axis. B is the vector 2, negative 3. 2 steps forward on the x-axis and then 3 steps downwards parallel to the y-axis. There's vector B. Both A and B have their tail at the origin, which is the usual way for drawing vectors. Now what happens if we add vector A to vector B? So we have 4, 1 added to 2, negative 3. So the x component 4 adds to the x component 2 to make 6. 1 adds to the number negative 3 to become negative 2. So let's see where that would be for vector C. Well, for vector C, that is 6 steps along the x-axis, followed by 2 steps downwards parallel to the y-axis, and there we are. We're at the tip of vector C, the red arrow. Now you can see that on the diagram, effectively A and B form the edges of a parallelogram. I've just put dotted lines to complete the parallelogram, and vector C is the diagonal of the parallelogram. This is sometimes referred to as the parallelogram method for adding vectors. Now, let's think about what it would mean if we did follow the instruction for vector A, 4, 1. It would mean starting at the origin, take 4 steps to the right, then 1 step upwards. That's where we'd be. From this point, if we followed the instructions for B, it would be 2 steps to the right, followed by 3 units downwards, and we end up at the same place. That's good. Now, I'm sure you won't be the least bit surprised to find that if we write these in the reverse order, I hope this won't be anything short of obvious. Two plus 4 is still 6, negative 3 plus 1 is still negative 2. So we could have, starting from the origin, followed the instructions for vector B first. 2 steps to the right, 3 steps downwards, then the instructions from this point for vector A, 4 steps to the right, 1 step upwards. So addition of vectors can be turned around without making any difference. We say this is the commutative property. So vector A plus vector B is the same as vector B plus vector A, just as it is for numbers. Now that's how we add vectors in rectangular or Cartesian coordinates. Thanks for watching.